My name is Shishpal Rawat. I'm the chairman of Accelerator. I also work for Intel. And this session actually had 3 presenters, one of which was hijacked by somebody here. So the first presentation was supposed to be from Faris on the Portable Stimulus Working Group. So he already made the update to you folks. So next we'll have on the new IEEE standards, we'll have a presentation from Tom Alsop and then from Karen Pieber. So Tom has been a principal engineer, is a principal engineer at Intel and works in the corporate design solutions
We
team.
have that, I think that's reversed. Wasn't it Karen first? That's her slides sitting up there.
No, it's just, Karen was last because she was going to participate in the lunch session and this was her lunchtime. Tom spent over 10 years working on CPU designs, including Pentium 4, Core 2 Duo, Core 3, i5, and i7 lines. He has been involved in system Verilog design community for a long time, currently serves as the UVM chair. And so Tom's here, so I'll let him get started. He's got a lot of experience in the system Verilog and UVM, and he is here to talk about UVM.
Excellent. All right. So I was asked to come present basically the history of UVM and the target trajectory of UVM in the IEEE. So what I've got here is basically a quick agenda. I'm going to try and drive through a lot of these foils. A lot of these talk about the history of the committee, what we've done, some of the milestones that we've had along the way. And what I really want to get to are the last couple foils that talk about the current direction in the IEEE, what we are planning to accomplish over the next year time frame, and what is the long-term strategy of UVM. So I'd like to get to that as quickly as I can. So when you look here at the history of UVM or design and verification, you see that system Verilog, as has already been discussed, has had this huge ascendancy into usage across the industry. This is just highlighting the growth of system Verilog. And the question came up and was actually posed earlier about the verification methodology and the need that the industry had in terms of being able to reuse the verification methodologies and base class libraries that were out at that point in time. So there was a point in time back in 2006 to 2008 when the EDA industry was creating their own incantations of verification methodologies, but there was not alignment, and so out of that came this push for a standard base class library, and hence the inception of UVM. So you can see here kind of the history and evolution of the verification libraries. You can see most of them were based off of system Verilog. You had AVM, ERM, OVM, you had VMM as well, and then ultimately we all finally converged on UVM. And that really was a very huge and significant milestone for the EDA industry. And that alignment took a lot of effort. In fact, I'll go through and talk about just briefly what happened historically in that committee. We didn't actually start out driving towards a unified verification methodology. We had a bridge that we created first, interoperability library that we created, which was the first part of the effort. So as far as standardization is concerned, we've had 3 major releases, and a lot of the effort here in terms of standardization was focused on bug fixes throughout the years. We had major releases, and then we had a bunch of minor bug releases that came out for each of these major releases. It was actually really interesting the way that the committee formed and progressed over time. Initially, we wanted to get something out the door as quickly as we could, which was a merged verification methodology, which turned out to be the UVM 1.0. We quickly realized that we pushed a little bit too fast. We came out with a 1.1 almost 6 months later because we had rushed things. But then from 1.1, we finally solidified on exactly what the spec was going to be. And then we realized that the industry wanted adoption of the standard, and because everyone was still using the older incantations. So we focused in the committee on how do we get adoption rates to go up. And the biggest thing we were being told by end users and by EDA companies was you need to get the bugs ironed out. And so we spent a good year going through, prioritizing, looking at the bugs that we had filed, finding out what was still wrong with the base class library implementation, and the focus was on getting adoption improvements. And it happened. Actually, I'll show you here in a minute. But there was a lot of focus on bug fixes. So we had all these different milestones. I won't go through them all. But basically, we're targeting these major releases, and then we had these intermediate bug fixes in between. And this shows here the adoption rates. You can see that UVM, when it first started out, it was very slow to adopt. It wasn't until we started focusing on those bug fixes. And then right before 1.2 came out, we saw some serious adoption growth with UVM. And it actually surpassed OVM back in September of 2012. So and since then, I don't even have the most recent numbers, but the adoption rates are pretty much predominantly across the industry. This is the de facto standard now. And it goes without saying, UVM is being used by pretty much everyone. You've got all these major companies, major EDA suppliers, all the major training providers as well. They're all on UVM. And so now we dive into basically the next phase in UVM. This has been owned by Accelerator now for the past 5 years, and we wanted to take this to the next level. So we've had this discussion with JEDA and other industry standards across the world, and we were trying to figure out how do we take UVM and the spec to the next level in terms of adoption across the Europe and in Asian regions. And so we decided, okay, we've got to take this course of making an IEEE spec out of UVM. So that effort started about a year ago. After we released 1.2, the focus was on creating a contribution for the IEEE. And so we ended up taking about 9 months of effort. We had these discussions about what really needs to be in the spec. And we ended up deciding a couple things. We decided, number one, let's clean up the spec. Let's prune back as much of the APIs in there as we can to make the initial introduction of IEEE UVM more of a skeleton, not necessarily a skeleton, but more of a base. This is what the end users are utilizing right now. So we ended up taking out a lot of the internal APIs that only the base class library was using. So there's a lot of focus on that cleanup. We also tried to clarify a lot of the language, just clarify how things were being described. And there was also a couple of minor API enhancements. We realized, okay, that's just not working. Let's clean it up now as we take it to the IEEE. And so we ended up finishing that work and started the IEEE effort back in June timeframe. We finally got the approval from DASC with our PAR to start a UVM committee within IEEE. And we've since now met for the past 2 months. What we ended up doing is taking a lot of first of all, we ratified the version of the spec that was being contributed from Accelerator that was ratified unanimously. So that's our starting point. And now we basically are taking the list of APIs that came out of, or all the Mantis tickets that describe, hey, we want this to happen for UVM going forward. We took that list of tickets, which is about 100 some odd Mantis items, and we walked through those in the IEEE committee. It was the first thing we ended up doing. We ended up taking 50 of those. That's going to be our starting point. And currently we're working to find owners for all of the tickets. And there's a lot of discussion now about creating subcommittees within the UVM working group so that we can parallelize the effort. So we've got a number of different technical subcommittees or sub-working groups which are being defined, scoped out, chartered, which potentially will have chairs assigned, and then we'll have different meetings to go and focus on those different subgroups and subtopics. So for example, TLM, I just wanted to highlight this one. One of the things that was highlighted is that within UVM, TLM is not, it's the way that we use it, the way that the API is used within UVM is different from the industry IEEE TLM spec. So there's going to be some focus to align the version of TLM that we're using and the APIs that we're using so that they match what's currently being used and released by the IEEE. So we've got a number of different subcommittees that are being worked on. Accelerator still actually is contributing to the efforts here. We've got an interesting model. The Accelerator committee is going to continue to own the implementation of the UVM, so the base class library will be owned by them. The way that we are going to manage the partnership between the two entities is that with clear definitions that the IEEE will own the specification, Accelerator will own the base class library, but we also are pushing the Accelerator committee to drive, we call it just to drive the IEEE spec. So as people introduce or want to see new enhancements, we want to see those tested out in the implementation ahead of time before they're driven into the IEEE. So it's just one channel that we'll use to feed new enhancements into the IEEE. But not to say that we're not accepting any enhancements from the IEEE committee or other sources. So we're targeting a 2016 release date. What we want to do is we have a short-term goal and we have a long-term goal. The short-term goal is we want to get something out the door quickly. We want the committee that's just formed to learn the process of how to do a standard, how to release it, and we have this focus of staying mostly solidified on the spec that we have with minor enhancements, clarifications, for example, in the TLM, getting those things cleaned up. But the real goal is to get something out the door so that we get the processes learned, but also with the focus of maintaining a system Verilog base class library or system Verilog API spec. We're not focusing on the initial release of having any type of language agnostic specification. We simply, because UVM is based on system Verilog, the intent is to keep it that way for the first release. We're trying to look forward, like in terms of industry adoption and line up what the industry will be using for 1.2, and then how long it will take for them to adopt the initial IEEE standard. Right, it's going to take us, for example, a year to get the 2016 spec out, and then really adoption for that, it's anywhere from people picking it up immediately, which is very rare, okay, to a year to 3 years time frame before that adoption really takes off. And so we're keeping that in mind, which is why we want to get the first version out. We want people to, use the 1.2 version that's there now. We're going to try and keep as many the change is minor in terms of going from 1.2 to the IEEE, and obviously have a backward compatibility very high on our mind in terms of keeping it backward compatible. And then the long-term trajectory, I've got it here. The long-term trajectory here on the bottom is a new standard in the 2020 timeframe, where we start looking at post 2016, when we start looking at a language agnostic version of UVM, meaning we're going to retrofit all the APIs. This clearly won't be as backward compatible as other releases we've ever done in the past, but really it's going to focus on, all right, how do we enable other languages? System C is a big one, right? Everyone's pushing for standard UVM System C, and so how do we enable that? And so those will be the bigger discussions that we'll focus on after 2016 release. So that's pretty much it. I don't have any more details. So questions? Stan?
Some changes in flight that are.
So I'm not aware of any like people going out and grabbing like the latest incantation in 1.2 and just pulling in automatically. Usually there's a lot of thought and planning ahead in terms of moving to a new major version of UVM. At least from Intel perspective, we're very careful about adopting the new version. But in terms of like when on a major release like 1.1, all the bug fixes we made, 1.1a, b, c, d, they were all backward compatible. Yeah, that was the intent. But when we've moved from the 1.0 to 1.1 to 1.2, those have been backward incompatible. Okay, but we've made every effort to not accept changes that make it backward incompatible. But on top of that, if we did and we saw that the benefit was there, then we made every effort to document exactly what the backward incompatibility issues would be and create automation for as much of that collateral that could be put through these automation tools and make it, update it so that it's compatible with the new version.
So if I think something's a bit out of whack, you would not mind getting an email from me, take a little bit more detailed look at that?
No, yeah, absolutely, yeah, send it my way. That's a good question. Yes?
Thank you very much, Tom.
Yeah, you're welcome.
Appreciate it.
You bet.
Okay, so we're going to have Karen come up here again to talk about Accelerator and IEEE standards and what's new. So Karen has served as the technical chair of Accelerator since the last 8 years, and also has seen the System Verilog working group work through 2 revisions of that standard. She's currently the Director of Software Operations for FPGA at Microsemi, and previously she has worked at Taboola and Synopsys, and she has also worked in the development of a Verilog simulation engine, and she has a PhD in computer science from Stanford University. So Karen, if you could please come and deliver your talk. Thank you.
Hello, one more time. So I was asked to talk a little bit about what's new in IEEE and in EDA standards, and I thought I'd start with what are the IEEE EDA standards. It turns out there are the high side of 20 of them, covering a lot of different topics and a lot of different time frames, and this is what's actively supported. So some of the older standards that were IEEE standards that haven't been renewed appropriately have dropped off this list. So this is what's currently checked off, been ratified recently enough, et cetera, on IEEE standards. Okay, next, there we go. Okay, so what are the trends in new standards development? One is that there are 13 active EDA PARs right now. Most of them are in STANS committees, in the Design Automation Standards Committee. There's continuing graduation of standards into the IEEE. You just heard an example of that with the UVM. We've had IP Exact. We've had several different System C standards come through to the IEEE. So the IEEE continues to be the gold standard destination for all the standards development that is happening. What I see in terms of trends is that there's a lot of standards development at higher levels of abstraction than we've seen in the past, looking particularly at unifying the various uses of technologies that are happening. Some examples, the IEEE 2415 and 2416 are looking at power modeling and at the system level. You've got the multi-language working group looking at how do we handle all these languages that we got and get them to work together well and consistently. You've got the debug data API, which is looking at a database API for doing waveform analysis so that we can have many different ways of collecting it and we can still use it in common tools throughout. We also see as we look through the new standards that are coming up that power and verification remain very, very strong themes in terms of the development that we're doing. Okay, What happens in new standards development? As I mentioned, there's some existing standard expansion that happens, but there's also several different paths to new standards development. One is the creation of a group within the IEEE, and 2415 and 2416 fall into this category. It never went to either an existing industry consortia like Accelerator Systems Initiative or SI2, nor did they create a new group like the Debug Data API group did or OVM did in order to do standardization. So it is possible to create a group from the beginning in the IEEE. It's also possible to use consortia, SI2, Accelerator Systems Initiative, to develop standards. And it's also possible to create new groups. And all of these have happened very recently. So all of these are active ways to create new standards and forward development. Where we are today in the IEEE is that there are 13 active EDA PARs. Lots of groups that call in, and I think one of these, the test group, 1838, actually reports not into Stan's DASC, but into another test organization. But there's lots of active work going on right now, both in terms of subcommittees of main committees that are going on, and in the case of System Verilog, we're about to start up new development, or we're about to have a meeting to decide whether or not we're going to start up new development for that language. In Accelera, we have a number of different working groups. The interface working group is looking at how do we communicate with embedded hardware, with emulators. IP Exact is doing modeling of various IP. Multi-language, as I mentioned before, is looking at how you cross languages. Portable Stimulus, you heard from earlier today. System C has a number of different committees working on various aspects of the language. System RDL is looking at how do we describe the registers and have multiple views of those registers depending on whether we're in test or we're in some kind of debugging. UCIS is looking at coverage tools and metrics. UVM you've heard from, they're moving to the IEEE, but there's ongoing development happening, in particular in the nature of updating some of the C software that we've got, C++ software we got behind it. And we've got an analog mixed signal working group, and that's actually now System Verilog analog mixed signal. At this point, we had a standard go out on Verilog, and we're looking at how to include System Verilog with it. If you look into SI2, they have a number of different coalitions on a number of different standards that they have under development and use at this point. If anybody's interested, I want to strongly encourage you to chat with me and some other folks, and we'll get you hooked up with the right people for some more data. And I'm going to end today with a blatant plug. New standards development and expansion has profound impacts on everyone. You have an opportunity to influence your career. You have an opportunity to influence what tools you work with. If you're a developer, you have an opportunity to figure out or to influence what you have to implement. Please take a moment and influence your future. All the standards groups need volunteers. If you're interested in any of the groups that I've mentioned, please contact the chair of an interesting committee, and I'm sure they'll figure out a way to get you to help and work with them. As I mentioned 2 or 3 times today, the IEEE System Verilog Working Group is discussing options for the next revision on Friday. So we've got that going.
Any questions for Karen?
Okay. Oh, Kevin.
Kevin. Otherwise, the question doesn't get picked up on. We're recording this, by the way.
I was just wondering how many of the groups are IEEE-SA only?
Do you know Stan?
I mean, the last time I participated in System Verilog, it was IEEE-SA only, and as an individual, that's kind of expensive.
The question was, to phrase it in more conventional terms, how many are entity-based? Yeah. So how many do you have to belong? Does a company or a university or a research lab join? And how many do individuals join? The answer is among the EDA groups that Karen mentioned, the 1076 VHDL and VHDL-A, that's 1076 and 1076-1. The 1647E language group are individual-based, and I believe every other one is entity-based. So the answer is almost all.
Other questions?
On the other hand, just to put it in context, the 802 groups, Ethernet and wireless, Wi-Fi and so forth, all individual based, but there's this minor thing that you have to pay over $1,000 to come to a meeting. Not to join the group, to come to a meeting,
Per meeting?
per meeting.
Holy cow.
So stop complaining. You got a good deal here. That's why your routers cost so much.
Okay,
Okay.
thank you.